my concern is now that we've gone from a case where some substations have been installed like those, which make it incredibly tricky to extend them for future development, to this case of going to a massively wide, standardised, build everything super big, which end up potentially making it incredibly challenging to consent it in the first place, which then might end up going from a 100-acre AIS solution to a smaller GIS solution built for the future.
Welcome to the Connectology podcast. I'm Hugh Taylor, CEO here at Road Knight Taylor, and in these episodes, our grid connection specialists, the Connectologists, dive into the evolving grid connections landscape, often taking expert guests with them in order to discover, generate, and share insights that might just help you and maybe even industry as a whole to connect projects faster, at lower risk, and at lower cost.
Hello and good morning, and welcome to another Road Knight Taylor podcast. I'm joined by Philip and Alex. So hi guys.
Hi Catherine.
Hi Mo.
And this morning we are talking about the risks of standardisation, and are we at risk of building too much grid? So in particular with a kind of a view to look at transmission, new infrastructure, in particular substations. We're quite keen to have a look at some of the projects that have come across our desks in the last kind of year or two, and look at perhaps some of the kind of trends that we're seeing in terms of how substations are designed, how that affects connecting customers, the timeframes for getting connected, and I guess whether are we gold plating everything, guys, or are we sort of trying to hit some sweet spots of future proofing? So Alex, maybe I'll come over to you to kind of like set up a background here, and perhaps give an example project as to why we're sort of talking about this and thinking about it.
Yeah, so we've got one project that we've been working on the last few years. So it has a bit of a history. So I think it originally contracted back in 2022. So it had a kind of small on-site substation. So this is a transmission project. And over the next few years, there were a lot of other customers kind of joining the queue. So in 2024, they were told by the TO that they were being rerouted to one of these new connection nodes, which might take 7 or 8 years more to construct. So this was a completely new substation. So the TO had to take siting studies, go through the whole planning, construction. So it would kind of pose a very significant delay to this project. Compared to the connection design that it had originally. Then when connections reform rolled around, we actually saw that the majority of those other customers who were contracted to that node kind of fell away. But it seems that NGET's policy was still to kind of drive on with this idea of this connection node, this future-proofed big substation, when we thought that the needs case for it had been kind of severely reduced.
So they went from a situation of having a lot of customers in one region that they thought they could connect into a connection node, and then post connections reform, that number has dropped significantly. It's what, 1 or 2 customers in this case,
something like that, yeah.
But the substation sort of design parameters effectively haven't changed.
Yes, yeah.
And I guess that sounds like that has a massive time frame impact on a customer, and a cost impact for the rest of us. I presumably building building that sort of like significant kind of 16-bay substation would have quite a high cost. I mean, we typically see, it's probably worth mentioning, we typically see sort of 400 kV connection node substations nowadays estimated in the kind of 150 million pounds ballpark, so which is a very, very significant step up compared to some of those smaller on-site single customer or kind of like sort of single loop in, loop out circuits that we used to see, which were probably, I'm going back a few years in terms of cost numbers, but we're probably more in the sort of 20 to 30 million ballpark. So I guess we're talking about big cost difference. Are there other differences as well? I guess I was thinking other kind of impacts in terms of like land take. Alex, you mentioned like land siting studies.
Yes, yeah. So those kind of big substations obviously need, a lot of land. I think some of the values that we all quoted it for this substation was something in the region of like 100 acres. Which I think actually huge. Budget, I think that's one of the biggest substations in all of the UK almost.
Yeah, which for two customers might draw a bit of the wrong kind of attention, I guess.
I think that the challenge with some of this is also, and this is part of the what should we end up doing? This is in a location which is close to some DNO customers and some DNO networks, and the question is around the coordination. And I'll be interested to know, Alex and Catherine, for this one. Do you feel like there has been coordination with the DNO for this region around would this new connection node have new SGTs that are going in there or not? And is that then going to be located in a location that's good for the original customer that triggered the need for the substation, the DNO with their network? Or is actually it going to be a hybrid where it's actually not good for anyone?
I do remember some of these conversations because after connections reform and lots of these customers have moved to Gate 1, actually the two remaining Gate 2 contracted customers in this case were the project that Alex is talking about, and the DNO who needed effectively a new GSP. But exactly your what you say is spot on, Philip. Those two projects had quite separate locational drivers. So, a DNO, obviously, if they want a new GSP, they're going to need to extend all of their 132 kV circuits to it and so on. They're going to have quite a lot of cost and locational drivers that say, well, we might want it, over here, please, to the TO. And, and obviously this project that Alex is talking about, is a consented renewable energy project. So it's got its fixed location, right? So you're already sort of trying to, in that standardization and saying, right, let's, build one big grid node. You're perhaps already having to compromise in terms of location. I suspect what puts the kind of nail in the coffin about whether you're ever going to get the optimum engineering design is if you're looking for 100 acres, that's a very large land parcel. So that's going to really potentially constrain you as to where you can then locate it. So I think that is true, that we should be careful about when you do standardize substations as very large substations. I guess we're saying standardized and future-proofed, then you are potentially making some compromises in terms of, are they going to be well located for your, even for your current customers, let alone your future customers that you don't yet know about.
And I think just to put it in perspective for everyone else, 100 acres, if you picture it, is a huge amount of space. A good example that I always point to, which is I think of a substation that's been very well done, is Stoke Baldorf substation. So a new GSP that came in around about 2012, 2015 in Enged's East Midlands region. A 2-transformer substation was initially put in, but there was space enough to go up to 4 transformers or for extra 400 kV connections. That one's built out as a smaller substation with additional space. That's 27 acres. So we're talking effectively
in total, including that extra space for future expansion.
In space, yep, exactly. That's tree screening, future expansion, all of the area for the wider element is 27 acres. So when Alex and Catherine are talking about a 100-acre substation, we're talking about something that's nearly 4 times as large of what a typically big GSP substation would end up being. So it's quite a big space.
Yeah, it's a massive difference.
Yeah. Philip, I guess that's sort of a good example of future proofing Stoke Bardolph, where you've got the land available to extend if you need to. Mm-hmm. Do you know how long ago they built Stoke Bardolph?
So that was 2012, 2015 that was put in there, and it was very much designed as this is a location that could need to have expansion. At the moment, I'm not aware that, I think it's been renamed as a connection node. I would presume that has been triggered. The question is, will it still be needed after all of the Gate 2 assessments, and which projects get Gate 2 offers and which ones don't?
So it sort of sounds like, there's 2 things at play perhaps. So one is our TOs, and perhaps particularly NGET, we're seeing this in England and Wales, looking to standardise on a design, so what they actually build, and I guess the things that are kind of driving those very large substations are, if that standard design is always things like a double circuit turn-in, so it's a full, you're turning in 4 400 kV circuits, for example. That's already making really quite a big substation. So I guess we could argue maybe there's just a need for some more standardized design. So maybe you have that for your super big nodes, and then we also need a standard, much smaller single circuit turn-in substation for your cases, like Alex's project, where actually maybe there's only 1 or 2 customers. I guess, are there other ways of future-proofing substations? So if you go for whatever kind of, you pick your standard type of substation based on the current needs, and then, I mean, Philip, you're sort of talking about space there. Is that just kind of like having a field to one side for future expansion, or is there a bit more to it?
I mean, I think the example of Stoke Bardolph for me is done perfectly. Not only have they got the field to the side, but all of the screening has taken into account the future expansion. So that one has been designed for having a double turn-in substation to go into that site. But I think also that the main area that always causes problems is things like cable corridors. You can end up having a substation in a particular area and then end up effectively having it sterilized. So I think there's more that could be done. And Stoke Bardolph is an example of one that is quite tricky to get into from a cable consenting perspective. But yeah, I think for me, it always feels like everything is a pendulum. We go from one way and then swing the other and then come back again. And obviously then there's time and then there's damage. And the answer is probably somewhere in the middle. A couple of other examples that I thought of substations that have been built recently that I think should have been bigger or should have catered for future expansion, which would be Braybrook substation, which is just south of Market Harborough, and Bulls Lodge that sits in between Rayleigh and Braintree. Those are two examples where I would say that there is a future needs case for additional SGTs in those regions. Both have sit relatively close to DNO networks that the DNO would probably have been interested in. If you were to look to the big picture, they probably would have warranted having bigger initial designs based on the wider needs case for GB. And my concern is now that we've gone from a case where some substations have been installed like those, which make it incredibly tricky to extend them for future development, to this case of going to a massively wide, standardized, build everything super big, which end up potentially making it incredibly challenging to consent it in the first place, which then might end up going from a 100-acre AIS solution to a smaller GIS solution built for the future expansion, that if we'd have found the middle ground, we probably could have ended up with a cheaper AIS design that's still going to be fit for purpose for the future.
Yeah, that really sort of chimes a chord with me, I think, this because I remember spending so long talking about anticipatory investment, which was sort of, do network operators have a kind of remit from the regulator to decide, well, actually, I should build in a bit more capacity or a bit more space on a kind of anticipatory basis. And for a long time, the answer to that was sort of no, wasn't it? It was very hard to do. So a lot of times people's hands were kind of tied, and actually the network operator had to build the least cost solution, even if there was a small incremental cost that would have made a big difference in future. That was probably really, really difficult for them to get approval for. So I suppose it sounds like we've kind of made progress on that, but as you say, Philip, we've kind of perhaps swung too far the other way. I guess, do either of you think, maybe it's a cheeky question, do either of you think this is sort of a strategy? So, is it easier to say, well, every connection node, when NGET have sort of named their new substations, which, aren't yet located and so on, they tend to have a connection node name, don't they? So sort of, whatever it is, South Yorkshire connection node B or something like that. So do you think it's a bit of a kind of strategy play to be like, well, let's decide that to begin with, every connection node is, a double turn-in, double bus bar arrangement, with a very large number of bays, and then we can slim it down from there? Do you think that's kind of like a strategy?
I think it's a strategy. I'm not sure it's a strategy that I would choose if I was in their situation. I mean, I think, as you've mentioned before, there's been possibly an absence of strategy, possibly bound by what the feeling was around what would be acceptable from a funding perspective. And I think at the moment we are in a very different, there feels like there's a different future funding capability, where in the past it was reducing costs, trying to use flexibility, trying to avoid building assets. And now it's a case of trying to build assets and plan for the future. I'm okay with the view of having, let's build big networks in key locations. I just think the answer is not to build it everywhere. That very early on, you should look at should this be a standard, very big, 100-acre, one of the biggest substations in the UK capability? And then I think very quickly you should probably get to the situation of actually that's not appropriate because that doesn't work for the DNO and ends up being a hamstrung design, which is good for no one. Or actually it's going to be a consenting nightmare and there's not enough CP 2030 gated capacity in this region to warrant doing this amount of connections, and that we should end up with a solution which is how far out should we be building and what is the realistic future forecast, which would then justify it.
Thank you for listening so far. If insights like these are valuable in your work, then feel free to subscribe and stay current as Britain's connections landscape continues to evolve. Now, back to the connectologists.
That's really a good point. So do you guys feel like, I mean, there's a bit of a difference, I guess, between saying you've got the contracted queue now, kind of post the gate 2 to the whole queue exercise, so which is really a sort of a CP30, so Clean Power 2030 to 2035 sort of remit. So I guess there's a bit of a difference between saying we are designing for that queue. That's not necessarily, it might be future proofing in the sense that you might be building a substation and the first person might connect earlier than the later people, but they're still contracted customers, versus future proofing for something else.
Yes, because I think that the question is kind of what is that something else? Because we still don't have the SSEP, so we don't know kind of what that's going to say. Again, the SSEP will still be kind of zonal, so it will be hard to say a specific substation will be optimal for something that the SSEP says. And again, that's something that will be updated every, I think it's 3 years. And so I think it is quite hard to justify that future proofing quite to that extent.
Yeah, and presumably that, it would be a bit cart before horse, because the SSEP was sort of meant to kind of like inform the network plan, the strategic network plans, and even those network plans, as you say, Alex, they're not down to we're going to build a substation in this particular location. They're more sort of looking at boundary flows and so on, aren't they? So it feels like you're kind of several steps behind knowing where you'd put a pin on the map for that strategic substation.
And I think at the moment there's an element of I think we might be doing it the wrong way around. This is my view. And the reason being is that we're looking at specific projects and then looking at building these nodes, which I think is going to end up being suboptimal from an overall GB PLC perspective, what's best for the country. What we as grid engineers tend to find is that a lot of the time people can be quite grid led, that if there is a substation in a specific location, and it feels like at the moment we end up with massive substations that are particularly rural and substations that are particularly urban. And at the moment we've had a massive growth of generation, and CP 2030 is looking at scaling that back. Now we've had a massive increase of demand, and then there's going to be a looking of demand reform as to which projects in the right area go and get accelerated. I think there should be the middle ground. We should be looking at building substations which have the capability of satisfying the urban demand growth in the logical locations where it's going to come, motorway corridors on the edge of big urban areas, future demand growth for domestic, industrial, commercial, that can also satisfy future generation connections in those regions. So you end up, rather than having massive new substations which are primarily for generation, and then the demand, it's quite difficult to put a huge data center, 1 gigawatt data center in a very green rural area, versus other locations where you build them, but it's incredibly difficult to put a solar farm on the edge of London, as an example, and trying to find the middle ground between them, which means we build the right assets in the right place at the right time with the future for expansion, and build it, and they will come.
Based on so Philip, is that a kind of a bid for, I guess, future proofing beyond the CP30, the kind of current grid queue?
Yeah, and I think so. And then looking at what could be consented in each of the different areas, and what is the ideal locations, and how do you build out DNO networks to feed into that, different substations, and a bit more coordination, which we're hoping that the RESPs are going to provide. But ultimately at the moment, they're not in the right place at the moment to have finished all of their work.
This is interesting. I think I might disagree slightly, Philip, because I think I'm very conscious of what Alex said, that actually and our current grid queues, CP30 and CP35, they already have a huge amount of demand in there, and I suppose, and realistically, I think, we're going to be building those connections for the next 14 years. I think we're still going to be building sort of the things that are at the back of the queue by the time we sort of hit 2040. So I'm wondering, I actually think maybe that's enough. That's enough future proofing. 14 years is a good horizon. Like once we get beyond that, we're not taking the most efficient economic decisions if we're building grid infrastructure now for stuff which is going to connect in the 2040s. So I think that I'm worried that people are going to use the crystal ball gazing sort of too far into the future and will get it wrong as a result and end up with potentially sort of expensive underutilized grid. And I suppose that's expensive for everyone. If an underutilized grid means that we all as bill payers end up taking our share of higher use system charges. So I guess it's just that time frame horizon. We sort of sounds like we kind of all agree that some future proofing is sensible. The cheap kind of future proofing, like land rather than building the assets, is more sensible. But maybe the hard question is what time horizon and what basis should you use for that future proofing?
I think the answer is probably somewhere in between us two, Catherine, which in some areas you do small and nimble because that's the right solution. And in certain areas, and I'm thinking a small number of areas, then you do the bigger and the grand, the ones that you have so much confidence that it's going to be the right answer. And still, as you said, buy the land, build the land in, build in this future space for the expansion so it can be done as and when it's needed. So I think the answer is probably not too much future stargazing. And so some of this, I feel like it would be great to go back in time and we should have been doing this 5 or 10 years ago, and then we'd be in a much better situation. So I think it's just trying to make sure that we're doing the right thing in the right place at the right time, which at the moment, I think we have the concern that there's not. I mean, a good example of that is probably one of the substations that's still being built at the moment, which is Biggleswade, which myself and Catherine had a hand in the development of that substation at the very early stage.
And went on a very proud cycle ride to go and see.
We did, yes, a very green visit where we turned up to a substation on bicycles for a client meeting, I should add, with a small detour. But yeah, at that point, that has been designed as a very simple loop in, loop out solution. 2 transformers. The network will be limited to 100 megawatts for SQSS P2 restrictions beyond having extra 132 kV interconnectors. That one isn't. I think it's about to be finished at the moment. It's sort of, I think, very close to being commissioned. That one was very clearly on the basis of this is the right solution for this area. But if you look at the tech register and the large demand register for those sites, at the moment, that would be the small nimble solution, but possibly would point towards that there's more needs case there than what's been built out. And adding a 3rd or a 4th transformer to that site is now very difficult because there's not the land or the connection strategy for it. So
but it is an example, I think, small and nimble, Philip. It's probably a very good example of building a substation relatively quickly. That's sort of been a 5-year development timeline, relatively affordably. Again, that's the sort of 20 to 30 million pound mark. So I think we shouldn't lose sight of those benefits where it's the right thing for the right location, actually, to go small and nimble. I think I'd be really sad if we've kind of lost that solution from the toolkit.
Yeah, and I think the question is when the demand increase, what is the next solution? Is it another small and nimble, or is it a much bigger strategic location that's needed and possibly designed earlier because the needs case for it is just needed, and that then help drive the small and nimble solution?
One last question, which is maybe a bit left field, but does if we as an industry, perhaps if the regulator kind of does give a clear remit to TOs, especially in the we're currently in the regulatory period T3, T4, a lot of these substations will be built in T4. If the regulator does kind of set this direction for T4 and say, eat your hearts out, go for it, we want future proofing, build big substations, does that take the pressure off? So does that have any other kind of I guess downsides in terms of how we're incentivizing TOs to efficiently use the network? Any thoughts on that?
I do worry that it will. So I think if we do stick to those kind of really big, double busbar, double 10 in substations, it kind of shifts the focus away from trying to optimize the existing infrastructure that we have. So things like bay sharing that I think we talk about a lot. I think that's a very good example of something that can be quite difficult. And if we have this policy of just building a new big substation, it's much easier to kind of reroute new projects to new substations than it is to figure out kind of very difficult technical solutions. I also kind of worry that it might stifle innovation as well. So if we just think back a few years ago, the idea of like tertiary connections were like a really good example of like using existing infrastructure or kind of repurposing existing infrastructure to give like new connection solutions. And again, something like that, I would find it difficult to see how something like that could happen or be prioritized if we do have this policy of just pursuing the new big node substations.
I think those are really good points.
I think bay sharing, love the idea. I think it's almost criminal to have a 100 megawatt battery connected to a 400 kV bay on its own. It's a very much an underutilization of it. Tertiaries, I struggle more to be infused by tertiaries because I think they might have done as much harm as they've done good in terms of derating SGTs and possibly is one that could have been missed in terms of the innovative solutions to go through because of the impact of derating of SGTs. So I think it's sort of trying to find the right solutions for me.
Fantastic. Oh, well, thank you very, very much. I think that's been a fascinating conversation, and a good one to bang the drum on bay sharing again, which Road Night Taylor are very much a fan of. Awesome. So I guess we'll see how this goes, and whether that pendulum sort of starts to stabilize, and obviously, if people have got projects where they are concerned that this kind of thing is affecting your point of connection, then I think that's something we're quite keen to sort of have a look at. Thanks very much, guys, and we will join you again shortly.
Thanks both.
Thanks both.
Thanks for joining the Connectologists in this exploration. This knowledge sharing is made possible by the support of our clients. We thank them and hope it will help the whole of industry to connect society's critical infrastructure faster. If you found this useful, you're welcome to explore more free insights at roadnighttaylor.co.uk/connectology or click on the Insights tab at the top of our homepage. Thank you.